Good morning. Today we're going to do 5.5, day 2 of notes. So we're still going to be factoring, but with a little bit of an added twist to it. Yesterday when we started factoring, we only had things like x squared plus 5x plus 6, let's say. We never had anything in front of the x squared. I mean, technically it was a 1 yesterday. Now, today, that will be something other than 1. And so factoring is a little bit different when that happens. So we're going to go through 2 different types of problems that involve a number out in front here other than 1. So here's our first rule. If every term has something in common, we're going to factor that out first, and then we're going to factor the leftovers. So here's our first example. You see how that leading coefficient is something other than 1. It's a 2. So according to this first rule, what I should do is I should see, is there anything common that I could take out of these 3 terms? And it looks like a 2 is what would be in common. And remember how in section 5.4 we took out that common factor? So we would write it kind of like 2 times x, and then we would have a 2x, and then we would have a 2 times a negative 20. And they all have a 2 in common. So what we're going to do is we're going to factor out that 2 out in front of the parentheses. And then what are we left over with? We're left over with x squared, and then an x, and then a negative 20. So now what we want to do is factor this remaining stuff. So this will now be more like yesterday's notes, where we are going to write our 2 sets of parentheses. And then remember, in order to make x squared, we would need an x and an x. And then what we would do is we would find 2 numbers that multiply to negative 20. Let me write that out. Multiply to negative 20. And because it's negative, they're going to have different signs. Meaning 1 will be positive and 1 will be negative. So let's think of all the things that multiply to negative 20. So we could have a negative 5 and a positive 4. We could have a positive 5 and a negative 4. We could have a 10 and a negative 2, or a negative 10 and a positive 2. We could have 20 and negative 1, or negative 20 and positive 1. Let's see, that's it, right? Those are all the things that multiply to negative 20. And now we want to figure out which combination adds to 1x. So we have to figure out which of these add to 1. The first 2, when you add them up, you'd get a negative 1. These 2, when you add them up, you get a positive 1. None of these other ones add to 1. So this is our combination, a positive 5 and a negative 4. So just to kind of recap, we took this 2 out, the common term of 2. We took it out in front, and it just stays out in front. And then the remaining stuff, the leftovers, we factor those just like we did yesterday. So let's try another one. So in this problem, I see I have a leading coefficient of 3. And what I want to ask myself is, does 3 go into all 3 terms? Because if it does, I'm going to take it out first. And yes, 3 goes into 18 and 3 goes into 24. So let's write it out so that we can a little bit easier see how, when we take a 3 out, what the leftovers will be. For 18, that would be a 3 times 6, and then there's an x. And then for 24, it would be a 3 times 8. So 3 goes into all three of these terms. So I'm going to take a 3 out. And then what am I left over with? I'm left over with x squared plus a 6x plus an 8. And now I want to factor those leftovers. The 3 is going to stay out in front. And then I'm going to write my 2 sets of parentheses. And I know 2 things that are going to multiply to x squared would have to be an x and an x. And now I'm going to list out all the things that multiply to a positive 8. And since it's positive, we're going to have same signs, both positive or both negative. So multiplying to 8, that could be a 4 and a 2. It could be a -4 and a -2, 8 and a 1, a -8 and a -1. Those are all the things that multiply to positive 8. And now we want to find what adds to 6. So out of all these combinations, this is the one that adds to 6. So a +4 and a +2. Okay, so when we see that leading coefficient, we want to ask ourselves, could we factor it out of all 3 terms? If it does factor out of all 3 terms, that's what we want to do first. Take it out and then factor the leftovers. Okay, so if we use that approach for this problem, we see that the leading coefficient is a 3, and I would ask myself, does 3 go into all 3 terms? So does 3 go into 10? Nope. Does 3 go into 8? Nope. Oh, bummer. So that means we cannot take a 3 out of all the terms. It's not going to work like this one did. And that's going to happen to you sometimes. So when that's the case, we have to do a different kind of factoring. And this factoring takes a little bit more thinking. So that's why Seth said we have to slow down and be careful. So we cannot take a 3 out. We're going to set up our parentheses. And now we need to say, okay, 3x squared is made up of our first 2 terms. So here and here. So I need to think of what 2 things would multiply to give a 3x squared. And those 2 things would be a 3x and an x. So that's what I'm going to put here and here, a 3x and an x. That's the only things that are going to multiply to a 3x squared. Now I'm going to look at my last term. And the 2 things that go here and here have to multiply to give me 8. Okay, and it's a positive 8. So that means they're going to have the same sign. So things that multiply to positive 8 could be a 4 and a 2, a -4 and a -2, an 8 and a 1, a -8 and a -1. Those are my only options. Now here's what's different. In previous FOILing problems, we would find the combination that adds to 10. But if you look, none of these add to 10. These add to 6, these add to -6, these add to 9, these add to -9. None of them add to 10. The reason why is because we've got this 3x and this x that's kind of messing things up a little bit. What we have to remember is that this middle term is made up of the outsides and the insides together. The outside 2 are these 2, and the inside 2 are these 2. I need to put these red numbers in these red slots, but I have to check my outsides and my insides to make sure that I get a 10x. So for example, let's say that I put, I'm going to put the 4 here and the 2 here. See, this combination of 4 and 2, it's going to matter now whether I put the 4 in the first slot or the 4 in the second slot. I'll show you. If you look at your outside 2, that's going to make a 12x. 3x times 4 is 12x. My inside 2, and I need to see, do those add up to 10x? And no, they don't. 12x plus 2x is 14x. So that's not going to work. That option is no good. So let's try something else. So again, I'm starting with my 3x and my x because they have to multiply to 3x squared. Maybe I'll still try this combination of 4 and 2, but maybe I'll put the 4 here and the 2 here. Do you see how last time I put the 2 first and the 4 second? Now I'm going to put the 4 first and the 2 second and see if that works. So I'm going to check my outsides. 3x times 2 is 6x. Check the insides. 4 times x is 4x. Those add up to 10x, which is what they were supposed to add up to. So, and that was a positive 4 and a positive 2, so I'm going to put my plus signs. That is the final answer. So the first two, 3x times x, made 3x squared. The last two, 4 times 2, made the 8. And then the outsides and the insides together, the 6x and the 4x, made the middle term, the 10x. There's going to be levels of guessing and checking involved. It's going to take a little bit of time, but the more you do, the better you're going to get at it. But it's going to take some time at first. So if you try a combination of numbers, try both orders. So the 4 could go first and the 2 could go second, or it could be possibly the 2 first and the 4 second, like that. And if that combination doesn't work, then you would go on to try the next one. So the -4 could go first, the -2 could go second, or you could flip the order. Same for all of these. It's possible you might have to try a whole bunch of them until you find the right combination. Sometimes you get lucky and it's the first one you try. Okay, let's try this one. So the first thing I do is I look at that leading coefficient of 2 and I ask myself, does 2 go into all 3 terms? 2 does not go into -3. 2 does not go into all 3 terms. If it did, that would have been great because we would have factored it out first, just like we did on these first 2 examples, but it does not. So we're going to set up our 2 sets of parentheses. The first 2 have to make up this 2x squared. The only thing that could be would be a 2x and an x. The last 2 spots have to multiply to give us -2. So the only options would be a -2 and a +1, a +2 and a -1. And just remember the order could switch. So the 1 could go first and the -2 could go second, or the -1 could go first and the 2 could go second. So these are all the different, maybe I'll kind of go like that. These are all the different combinations. We have to just try one out. So I'm going to try this first combination. I'm going to try the -2 and the +1, this first combination right here. Let's see if it works. How do we know if it works? We got to check the outsides and the insides, because the outsides and the insides together need to make a -3x. The outsides make 2x. 2x times 1 is 2x. The insides make a -2x. What do you get when you add those up? -2x plus 2x is 0. That's not what we want. We want a -3x. So this is not going to be any good. That did not work. So let's try again. Set it up with our 2x and our x. And now maybe let's try this combination. So let's put a +1 and a -2. And we got to check our outsides and our insides. The outside 2x times -2 would be a -4x. The inside 1 times x is 1x. What do you get when you add those up? You get -3x. That's what we wanted. Whoops, I didn't mean to cross it out. I meant to circle it. So -3x is what we wanted this whole time. So that means that we did it. This is the right answer right here. So this combination would not have worked and that combination would not have worked. Sometimes you try one, it doesn't work. You try another one and bingo, it works. Let's try another one. So again, I look at the leading coefficient, which is a 2, and I ask myself, does 2 go into all three terms? In this case, no. 2 does not go into all three terms. Okay, so that means it's the more complicated kind of factoring. So the first two spots have to make a 2x squared. So that would be a 2x and an x. The last two spots make up a -3. They have to multiply to -3. So write out all the combinations that would multiply to -3. It's negative, so they're going to have different signs. So it could be a +3 and a -1. It could be a -3 and a +1. Or the order could change. The -1 could go first, the 3 could go second, or the +1 could go first, and the -3 could go second. So like these are all the different combinations we need to look at. So we just try one. So let's try the first combination. Put a 3 here, a +3, and put a -1 here. We have to check our outsides and our insides. The outsides and the insides have to make a -5x. So if I look at my outsides, 2x times -1 would be a -2x. The insides would be a 3x. And when we add those up, we get a 1x. And that's not what I want. I want a -5x. So that's no good. So then we try a different combination. So let's try this combination. Put a -1 here and a +3 here. Check the outsides. 2x times 3 would be 6x. -1 times x would be -1x. When I add those up, I get a +5x. But I want a -5x. So I'm closer. I got the 5 part, it's just the wrong sign. This is a +5x. So that's not going to work. This combination did not work. But I'm closer because I got the number part right. I got a 5. I want a -5. So what that would indicate is maybe all I need to do is just change the signs. So instead of a -1, make it a +1. And instead of a +3, make it a -3. That would be this combination right here. Let's try that. So the outside 2 would be a negative 6x. The inside 2 would be a 1x. Those add up to negative 5x. So that is the correct combination. This would be the correct answer. So it's going to matter whether you put like the negative 1 in the first spot or the negative 1 in the second spot. The 3 in the first or the 3 in the second. The order matters. So you have to be a little bit more careful with this kind of factoring. It's going to take a little bit more guesswork, a little bit more checking. Let's try another one. Okay, so again, anytime I see a problem with the leading coefficient, I ask, does it go into all three terms? 4 does not go into 5. 4 does not go into 1. 4 does not go into all three terms. All right, so set up your two sets of parentheses. The first two terms have to give us a 4x squared. So let's try a 4x and an x. The last two terms have to multiply to give us a 1. Well, our only choice is there, since it's positive, they'd either have to both be 1s or they'd have to both be negative 1s. So let's just try both of them being a 1. We have to check our outsides and our insides to make sure that they make a 5x. So the outside 2, 4x times 1 is 4x. The inside 2, 1 times x is 1x. Add them up. Yep, those equal 5x. So we did it right on the first try. That's the answer. But I just wanted to point out, when we started making our two sets of parentheses, two things that multiply to 4x squared could also have been a 2x and a 2x. And then two things that multiply to a 1, let's try the 1 and the 1. Check the outsides and the insides. The outsides would be a 2x. The insides would be a 2x. Those added up do not make 5x. So this actually does not work. So the idea is there's only going to be one right answer. There's only going to be one way to factor. But it does kind of involve some guessing and checking until you get the right combination. Bottom line is you got to check the outsides and the insides. So just a reminder, these beginning problems, these were nicer because that leading coefficient, that 2 went into all three terms. So that's what you want to check for, because if you can take out a common term of 2, see how the leftovers are now the easier kind of factoring like we did yesterday? That's ideal. Same thing here. 3 went into all three terms. We took the 3 out first and then factored the leftovers. That number out in front stays out in front. It doesn't go away. It stays out in front. But check always to see if every term has something in common first. Because if it does, it's an easier kind of factoring. If it does not go into all three terms, like here 3 does not go into 10 or 8, then it's the trickier kind of factoring. So take it slow, leave yourself room to try different options. And yeah, so you can work on your worksheet for homework now. And that's it. Have a good day.